From the dawn of time, humans have gazed up at the night sky, our curiosity ignited by the celestial tapestry above. The stars, planets, and other celestial bodies have always been a source of wonder and inspiration, leading us to question our place in the universe and the nature of the cosmos. Among the twinkling stars, one celestial body has captivated our imagination like no other: Mars, the red planet. Its distinct reddish hue has made it a standout object in the night sky, drawing the attention of astronomers and dreamers alike for centuries. Throughout history, Mars has been an object of fascination, inspiring countless myths, stories, and scientific inquiries. Ancient civilizations wove tales around this mysterious planet, attributing it to gods of war and agriculture and seeing it as an omen of significant events. Its reddish hue, visible even to the naked eye, hinted at a world both familiar and alien, fueling dreams of one day unraveling its mysteries. This unique color, caused by iron oxide or rust on its surface, has always set Mars apart from other planets, making it a symbol of intrigue and curiosity. Early astronomers meticulously tracked Mars's movements, charting its course across the heavens. They noted its retrograde motion, where it appears to move backward in the sky, a phenomenon that puzzled and fascinated them, leading to various theories about the structure of our solar system. With the advent of telescopes, we got our first glimpses of its surface, revealing polar ice caps and dark, enigmatic markings that some interpreted as canals, sparking speculation about Martian life. These early observations, though primitive by today's standards, opened up a new world of possibilities and questions about the red planet. These early observations, though limited, only deepened our fascination with the red planet, setting the stage for our modern-day quest to explore and understand our celestial neighbor. The idea that Mars could harbor life, or at least once did, has driven scientific inquiry and exploration for decades. The space age marked a turning point in our relationship with Mars. With advancements in technology and a growing desire to explore beyond our planet, humanity set its sights on Mars, aiming to uncover its secrets and understand its place in the solar system. No longer content with observing from afar, we sent robotic emissaries to pierce the veil of distance and uncover its secrets. These missions, equipped with advanced instruments and cameras, have provided invaluable data and images, bringing us closer to understanding Mars than ever before. From the Mariner probes, which provided the first close-up images of Mars, to the Viking landers, which searched for signs of life, each mission has added a new piece to the puzzle, gradually painting a more complete picture of this enigmatic world. These missions have revealed a planet with a complex history and a dynamic environment, far more intriguing than we ever imagined. Today, our understanding of Mars has grown by leaps and bounds. Modern rovers like Curiosity and Perseverance have explored its surface in great detail, analyzing soil samples, studying rock formations, and searching for signs of past life. These missions have provided high-resolution images and a wealth of data, transforming our knowledge of the red planet. We know it to be a cold, dry, desert world, but one that bears striking similarities to our own planet. Mars has mountains, valleys, and even weather patterns that resemble those on Earth, making it a fascinating subject of study for scientists and a potential destination for future human exploration. Evidence suggests that Mars was once a much warmer and wetter place, with flowing rivers, vast oceans, and perhaps even life itself. Ancient riverbeds and lakebeds, along with minerals that form in the presence of water, indicate that Mars had a significantly different climate in the past, one that could have supported life. This tantalizing possibility, coupled with Mars' proximity and potential for harboring life, has made it a prime target for future exploration, igniting a global effort to one day send humans to the red planet. International collaborations and ambitious plans for manned missions to Mars are underway, with the goal of not only exploring but potentially colonizing this intriguing world. The dream of setting foot on Mars is closer than ever, and the red planet continues to beckon us with its mysteries and possibilities. The quest to understand Mars's past and its potential for life has fueled one of the most ambitious scientific endeavors ever undertaken. This mission is not just about exploring a distant planet, it's about answering fundamental questions about our own origins and the potential for life beyond Earth. The Mars Sample Return Mission. This mission represents a monumental leap in our ability to study the red planet. providing us with the tools to unlock its secrets in ways never before possible. This groundbreaking mission, a joint effort between NASA and the European Space Agency, aims to do what no other mission has done before: bring Martian samples back to Earth for in-depth analysis. This collaboration highlights the importance of international partnerships in advancing space exploration. By bringing Martian samples back to Earth, scientists can conduct a wide array of tests and analyses that are simply not possible with the instruments currently on Mars. This will allow for a much deeper understanding of the planet's geology, climate history, and potential for past life. Why go through the trouble of bringing samples back when we have sophisticated rovers exploring the Martian surface? The answer lies in the limitations of even the most advanced robotic explorers. While rovers can perform remarkable feats of science, their analytical capabilities pale compared to the state-of-the-art laboratories we have here on Earth. The rovers are equipped with a suite of scientific instruments, but they are limited by their size, power, and the harsh conditions of the Martian environment. They can only carry out a fraction of the tests that can be done in a well-equipped Earth laboratory. While rovers can perform remarkable feats of science, their analytical capabilities pale compared to the state-of-the-art laboratories we have here on Earth. By bringing Martian samples back to our planet, scientists can subject them to a battery of tests and analyses that are simply not possible with current rover technology. By bringing Martian samples back to our planet, scientists can subject them to a battery of tests and analyses that are simply not possible with current rover technology. This includes detailed chemical and isotopic analyses, high-resolution imaging, and even biological experiments to search for signs of past life. The Mars Sample Return mission is a complex multi-stage endeavor. It involves several spacecraft, each with a specific role to play in the collection, transfer, and return of Martian samples. It begins with NASA's Perseverance rover, which is already diligently collecting rock and soil samples from promising locations within Jezero Crater, a region believed to have once been a lake bed. This ancient lake bed is of particular interest because it may have preserved signs of past microbial life. These samples are being carefully sealed in airtight tubes, awaiting their eventual return to Earth. Each tube is meticulously catalogued and stored to ensure the integrity of the samples during their long journey back to our planet. A future mission, slated to launch later this decade, will send a lander to Mars carrying a small rocket capable of launching the samples into Martian orbit. This lander will also carry a fetch rover designed to retrieve the sample tubes from the surface and load them into the rocket. Once in orbit, the samples will be rendezvoused with an ESA-developed spacecraft that will capture the precious cargo and ferry it back to Earth. This intricate dance of spacecraft requires precise timing and coordination to ensure the safe transfer of the samples. The successful return of Martian samples would be a watershed moment in our exploration of the Red Planet. It would mark the first time that material from another planet has been brought back to Earth for study, opening up new frontiers in planetary science. It would provide an unprecedented opportunity to study Martian rocks and soil in exquisite detail, potentially unlocking secrets about Mars's past, including the possibility of ancient life. The data gleaned from these samples could help us understand the planet's geological history, climate evolution, and potential habitability. These scientific discoveries from these samples could rewrite our understanding of Mars and our place in the cosmos. They could provide clues about the early solar system, the processes that shaped our own planet, and the potential for life elsewhere in the universe. This mission is not just about Mars, it's about our quest to understand the broader universe and our place within it. India's triumphant entry into the realm of Mars exploration with Mangalyaan-1, also known as the Mars Orbiter mission, in 2014, captivated the world. This mission was a monumental achievement for the Indian Space Research Organisation, or ISRO, as it marked India's first interplanetary mission and made India the first Asian nation to reach Martian orbit and the fourth space agency in the world to do so. This groundbreaking mission, achieved on a shoestring budget, showcased India's growing prowess in space technology and cemented its place among the elite spacefaring nations. The success of Mangalyaan-1 was not just a technological triumph, but also a testament to the ingenuity and dedication of the Indian scientists and engineers who worked tirelessly to make it happen. Now, India is preparing for its sophomore voyage to the Red Planet with Mangalyaan-2, an even more ambitious mission that aims to build upon the successes of its predecessor. This new mission is set to push the boundaries of what has been achieved before, with more advanced technology and a broader scope of scientific objectives. Mangalyaan-2 represents a significant leap forward in India's Mars exploration program. It is not just a follow-up mission, but a bold step towards deeper space exploration, aiming to answer some of the most intriguing questions about Mars and its potential to support life. While Mangalyaan-1 was primarily a technology demonstration mission, Mangalyaan-2 is designed to delve deeper into the Martian mysteries, carrying a suite of scientific instruments to study the planet's atmosphere, surface, and subsurface. These instruments will provide critical data that could help scientists understand the planet's history and its potential for future human exploration. The mission will consist of an orbiter, lander, and rover, a significant upgrade from Mangalyaan-1's orbiter-only configuration. This trio of spacecraft will work in tandem to provide a comprehensive analysis of Mars from its orbit to its surface. The Mangalyaan-2 orbiter will continue the work of its predecessor, studying the Martian atmosphere for signs of methane, a possible indicator of past or present life. Methane detection is crucial because it could point to biological processes or geological activity, both of which are of great interest to scientists. It will also carry more advanced instruments to map the Martian surface in greater detail and study the planet's magnetic field. Understanding the magnetic field is essential for learning about the planet's interior and its geological history. The lander, designed to touch down on the Martian surface, will carry instruments to analyze the composition of the Martian soil and search for signs of water ice beneath the surface. Water ice is a key resource for future human missions, as it can be used for drinking water, oxygen, and even rocket fuel. Perhaps the most exciting element of the Mangalyaan-2 mission is the inclusion of a rover. This rover will be equipped with state-of-the-art technology to navigate the challenging Martian terrain and conduct scientific experiments on the ground. This six-wheeled robotic explorer will be India's first foray into surface exploration on Mars. It represents a significant milestone for ISRO and showcases India's growing capabilities in robotic space exploration. Equipped with a suite of scientific instruments, the rover will traverse the Martian landscape, analyzing rocks, collecting soil samples, and beaming back valuable data to Earth. This data will help scientists understand the planet's geology and climate, and could provide clues about the planet's potential to support life. The Mangalyaan-2 mission is not just a testament to India's growing space capabilities, but also a beacon of inspiration for future generations of scientists and explorers.